Good morning. Yes, today we are supposed to start the weekly paper number 9, the discussion. We'll come to that first. Pavita, make a Venema recording. Yes, paper, weekly paper number 9. Take question number 1. Yes, read question number 1, paper 9, weekly paper number 9. Question number 1, right. There you are given two cars A and B starting from rest from a point O. Right. Two cars starting from rest from a point O here. Right. And then the car A is here. Car A is here. Yes, that moves with acceleration 2f. Suppose this direction. And the car B, right here, move into opposite direction, right? Remember. Car B is this, move into opposite direction this way with acceleration f. After a time t, car A begins to travel with uniform velocity it has acquired. At time t equals t, right? Car A is somewhere here. Suppose car A is somewhere here. At that moment, because of its accelerating motion 2f, it will have taken a certain velocity, suppose v. We are given in the question, after the moment t equals t, this car A continues its journey with the constant velocity v till the end of this question. Okay, that's how it says, right? Now at the time t, the car B is somewhere here. Car B is somewhere here. Suppose at time t equals t, car B is somewhere here because that also moving with acceleration in the left this way, right? Car B is here. Car B here. But that moving still to the left hand side with acceleration f. It has traveled a distance this. It has traveled to the left distance this. Okay, suppose that distance as x. During the time interval t, A moves to right a distance y. Right, like this. Then what is it saying? At time t, car B meets another car C moving to opposite direction of B. Right. At time capital T, car B is here. We are given car B meets another car C moving to opposite direction of B. Here, once the car B passes to left, this moment, another car C is traveling toward rightward. Understand? Right? If the velocity of this B at that moment I take as suppose W, we are given what? the car B meets another car C move into opposite direction of B. That means to the rightward direction only C now moves. With what velocity? With the speed of B with uniform acceleration F. Right. So then car C is, we are here. Car C is here now. I draw the car C here like this. Car C here. Okay. Car C here, right. Car C moves with the velocity W rightward with acceleration F. Like this. Understood? So therefore, car C at time t is at a distance simple x left of the point O. Right? Now what happens is car C and car A, they move to same direction. After the time capital T, car A moves with constant velocity, but during the end time motion of car C with initial velocity W, it moves with acceleration F. Because of the acceleration motion of car C, it will increase the velocity. Because of this one moment in the journey, this C, car C can overtake what? Car A at one moment. Understood? Okay. Then shall we draw the VT graph? Yes. I'll start to draw the VT graph. Okay, right. Then car A and car B starting from rest, right. So then I am going to draw. I take this direction as people positive direction. Then this direction should be negative direction. Okay. Then car A starts from rest. That should begin the motion from here. Time 0. Velocity 0. That moves like this with acceleration 2f, right? Let us take this angle as alpha. Then tan alpha is acceleration of car A given 2f. Okay. After time t, right? I'll take time t here. After time t, it will acquire certain velocity. No. This is the time t. Okay, this is the time t. Of time t, it will get certain velocity. I have assumed that velocity as v in the case, right? Now, thereafter, A moves with constant velocity like this, right? This is the motion of A, right? Now, B moves to the left. Therefore, its velocity is negative. Then the VT graph of B should be below the time axis. You agree with me? Yes, below the time axis. Okay. And also its acceleration is F, smaller than acceleration of A. So therefore, we should have VT graph of that B like this. With the blue color, I am drawing that. Right. Let us take this angle as beta. Right. The tan beta is F. Tan beta is F. Right. This time is T. This time is T, right? This time is T. Okay. Now, we can calculate the velocity of B. The velocity of B. We can calculate the velocity of B at time t. Okay. Velocity of B at time t we can calculate here. This velocity I need this velocity. That velocity only, people, I have taken as at time t. Velocity of B only I took as w. Clear? At time t, velocity of B I took as w. Then where should be w? This, no? This should be. Why? After time t, velocity of B is given by this height, no? Right. This is, people, w. That should be minus w. Reason? It's a negative velocity. Right. Now, the same w, with the same w only, C now moves to what? Rightward. Then how do we mark? You can very clearly understand, out of this V and W, which one is bigger? V should be bigger. Reason? It has more inclination, tan alpha 2f, no? Therefore, this height should be greater than this height. Am I correct? When you calculate this, you will get that answer. Right. We will calculate that. Now, cos C moves, right, to the right at time t only. We actually discuss the motion of C. Before time t, we don't know what was the motion of C. So therefore, at time t here, the velocity of cos C is this w. Right here. Okay, this is the velocity w of cos C. Now cos C moving to right, then its velocity should be what? Positive, and displacement should also be positive. It moves with acceleration, people. If, then how should I draw the VT graph of cos C? Yes, it should be like this, no? This is. This is the cos C. We are given the acceleration of cos C as simple f. Then tan beta is f. Then what could be this angle? Should also be beta, because tan beta should be f. This is beta, yes. This is beta. This angle should be beta. Reason? Tan beta only f. Therefore, to get f acceleration, the angle should be chosen is beta. Understood? Right. So therefore, right, this way we have the VT graph of C. This is A. Right, okay. Now we shall calculate. Right, people, now I'll ask one question from you. Suppose somewhere here, right, car A here, car A here now, right. Because of the accelerating motion of cos C, it increases the velocity, and one occasion cos C can overtake the car A. You agree with me? Is it possible? Car C can overtake car A. Is it possible? Possible. Reason? Car A begins to move constant velocity v. One occasion car C gets the velocity v. Since during its whole motion car C moves with acceleration, one occasion car C exceeds the velocity v and going above that value v. Thereafter, every moment, since the car C has more velocity than car A, gradually car C coming behind and coming closer to what? Car A. One occasion, therefore, car C can overtake car A. Right. Okay. Then I am going to draw the moment car C overtake people, the car A. Okay. People then tell me, if I take from O the whole distance traveled by the car C as this Z, from O, the whole distance traveled by the car A is Z. Can somebody tell me what distance the car C should move to overtake car A? What distance this car C should move to overtake car A? Car C is starting from here, people. At the moment of overtaking, car A and C both here. From here to here, distance I took as Z. But car C starts simple x distance behind O. Then once the car C overtakes the car A, what distance the car C must move? Yes, this x plus what? Z, no? This x plus Z. Am I correct? X plus Z. Understood? Right. Now we go to the calculation part. Right? Okay. Right. Now, here, what is next asking? The car B moves with the uniform velocity it has acquired at time 2t. Yes, we have to identify what is the time 2t, right? So that one, I am going to first calculate, people. This V, this W I am going to calculate. V can be calculated how? Apply tan alpha ratio here, opposite side divide by adjacent. Calculate V. Here apply tan beta ratio, calculate W, right? Come to the answer. By the diagram, write down. By the diagram, tan alpha here, V over T, But tan alpha we know 2f, V over T. Then V equals 2ft. Right. Come to here, tan beta W over T, tan beta W over T, right? Tan beta if used in cross multiplication by T. Ft equals W, W equals Ft. Right, no? Now we can see V is 2 times W, V greater than W, right? That's fine. Right. What is asking next? Draw the velocity time graph for the cars A, B and C from their start until the car is overtaken by car C. Find the time the velocities of A and C are equal. Can you show me the time moment velocities of A and C are equal? People, you know, when you come to this point, look at this point. Here there is a corresponding time. I can find that time by drawing vertical line like this here. Look at this. Look at this vertical line here. Here. Once I draw vertical line here, that means time axis here. Okay. At this moment, the velocity of C given by this height, velocity of A given by the same height. You know, heights being equal. Therefore, what can you say? At this time, the velocities of A and C are what? Equal. Understand? Okay. Now ask him to find this time. Right. If I take this time as, people, simple t, I take this time as simple t. Ask him to find that time t. Then I can find it like this. right? I'll name this VT graph like this. This is O, here A, and this is, yes, I'll mark that later. This is H. According to my diagram, I will mark, then it's much easier to consider, right? Then I can now find this way. In the triangle this, we can write tan beta. What is tan beta? The opposite side this, divided by the adjacent this, okay? Right. Then this opposite side you can write how? Whole height is V from here to here, W, what is this? V minus W divided by T is the tan beta, okay? Right. Then you can write again by the diagram. Tan beta, this is V minus W divided by T, V minus W divided by T, simple T, right? Correct, no? Substitute for tan beta. If we know this V, 2F capital T, we know this W, Ft, divided by T. The F letter left and right you can cancel down. Here we have 1. Then here 2T minus T, it's capital T divided by T. Bring this here, T equals T. Okay, right, this is T again. Right, you can clearly understand I did not complete the VT graph of B. Reason people, we are given in the question somewhere what? The car B moves with uniform velocity it has acquired at time 2t. The time 2t we had to find. So now we found time 2t. This is t, this is t. Then the time 2t mean what? The moment the velocities of A and C become equal. Right. Then time 2t is this. Okay, like this. Now, this is the time 2t. After this, what happens? Car B moves with constant velocity. Understood? Right? Okay. Like this. Okay. Right. This is the motion of car B. Right. I'll take people this as our moment, the car C overtakes the car A. Up to that moment only asking to find the VT graph. Now only we have completed drawing the VT graph. Right, no? Right. Who got this VT graph correctly? Yes, good. But remember people, this time also should be here. If you don't find this time correctly, now that means if you have started the uniform motion of B before this time, your VT graph is wrong. You lose some marks for that. Understand? So therefore, some occasions before drawing the complete VT graph, some data we have to find. Subject to that data only, we can continue to draw the VT graph. Understand? Right. Okay. This way, now it's correct. Now I'll mark the points like this. Here, this point I have taken as F. I take the same points. This is F, and this point is B. This point is B. This point is C. This point is J. This point is I. Right? This point taken as G. This point is D. This point is E. Right. These are the points, okay? Right. This is VT graph. So then you get full marks. So very important thing, people, in this case, you must identify positive direction and negative direction first thing. The time 2t, what is exactly time 2t? After that moment only B moves with constant velocity, right? That is VT graph, okay? I didn't see so far in the past papers questions under VT graph having 3 objects. There's a chance of coming, okay? Relative velocity, that means the second part of the same question. You know this question coming in the applied maths paper, part B, very first question. That means in the oral paper, 11th question. 11th question has 2 parts, A and B. Part A coming from velocity time graph, part B coming by the lesson, from the lesson relative velocity. In the relative velocity, until the recent past, there were 2 objects in the question, but now coming with 3 objects, okay, relative velocity. Therefore, the same thing may be applied for the VT graph also. That is why I put this question, okay. Now we go to the calculations, right? Find the time the velocities of A and C are equal that we found. Question number 2, answer is T, right? That's correct. Find the time taken by C to overtake A from the initial moment of A. Initial moment of A means, people, from here, right? That means we have to take, this is the moment C overtakes A. C overtakes A, right? C overtakes A is here, right? This time we need to find. We'll take this time as T1. That T1 we need to find. Right, people, now, right, in this diagram, I have marked. When this C overtakes A, the distance moved by C, what? Here X, here Z. Understand? Distance moved by C should be X plus Z. Understood? Can somebody tell me, when C overtakes A, that distance moved by C is given by a particular area? Can somebody show that area? If this is the moment C overtakes A, up to this moment the VT graph of C is this. VT graph of C starts from here. From here to here, the area covered by the VT graph of C going to be what, people? Here, DEFC. Am I correct? Then this DEFC should be equal to what? X plus Z. Am I correct? Am I correct? Yes. Correct, no? Right. People, what is this X? During the time capital T, the distance moved by B to leftward. During the time capital T, here, B has moved a certain distance. It is given by what? ODG area. Am I correct? Then this X I can write how? This is equal to ODG area. Am I correct? During the time T, the displacement B moves leftward. During the time T means this is time. During that time, VT graph of B is from here to here. The area covered by that is given by ODG. That ODG area is equal to what? This X. Am I correct? Yes. Next one, people, until the overtaking takes place, from the start, what is the displacement traveled by the car capital A? Car capital A VT graph is this. Okay. The overtaking is taking place here. Then up to here, the VT graph of A valid now from here. Then tell me, up to this time moment, the area, what OABC area, that OABC area should be what? The distance moved by A just before it is overtaken by C. Understand? Am I correct? Huh? OABC area. OABC area is the displacement traveled by what? A just before it is overtaken by C. Then what is this Z? Z is given by what? OABC area. Am I correct? Am I correct? Yes or no? Yes. Right. Now we told what? When this C overtakes this A, C must move a displacement what? X plus Z. But we know the displacement traveled by C, its motion starting from this moment. Overtaking is happening here. Then the total distance traveled by C is going to be DEFC area. Am I correct? Right. So therefore, this DEFC area should be equal to what? X plus Z. Am I correct? Okay. Write down like this. Write down. When C overtakes A, when C overtakes A, when C overtakes A, the distance it moves, the distance it moves is X plus Z. Is X plus Z. Right. Your X given by Y, what? ODG triangle area. Is it clear? X is ODG triangle area. Why? During the time t, the distance traveled by B to the left. During time t means this time. VT graph of B is from here to here. The area covered by that is X. Right. Write down. Therefore, yes, the distance traveled by C is going to be DEFC. DEFC area. DEFC area is equal to what? X plus Y, no? What is X? X given by ODG area. ODG area plus Z OABC area. OABC area. People, now you can see in the left hand side, DEFC area means this, no? DEFC area. Right. For that area, and this on the right hand side, OABC area. OABC area. There is a common area. Can you identify? What I'm trying to tell you is for this one and for this one, there is a common area. What is that common area? You can see for that the common area is this, no? Look at this. Can you see this has the common area for that both? Yeah. DEFC area here. DEFC area that contains this. Okay. OABC area. OABC area. That also containing this. Then what can you say? We can remove the common area from both sides. Understand? We can remove the common area from both sides. Clear, no? Yes. Now write down. Removing, write down here. Removing common area from both sides. Removing common area from both sides. Removing common area from both sides. Right, people then tell me from DEFC, DEFC, from that we remove this part. What is remaining now? This BHF area. Am I correct? BHF area, right. Then the left hand side we have BHF area. Right, we'll write ODG area here. By this OABC, OABC, we remove this. Then tell me the remaining area. OAD plus AEH. Am I correct? By OABC here, OABC. From that, this part we remove. What is remaining now? This part and this part. OABC, right. Then that is OAD area plus what? AEH area, no? AEH area. Right. When you have this common area, people remove that common area, don't take that into account. Why? More calculations then. Right. Now we will write the equations for this. Right. Right. Now you know this angle beta, therefore this also beta. To find this area, we need this height. We need this height. Right, no? I have assumed this time as T1. I have assumed this time as T1. Okay? Then, using tan beta ratio here, you can find this height. Right, we'll keep this as star. In the next moment, we're supposed to substitute. Right, we need the area this. We need the area this. We have enough data to find those areas. To find this area only, people, we need this height. To find this area also, we have the enough information. So therefore, that HFB area, to find that, we need this height. Then apply what? Tan beta ratio to this and get now this height BF. Right? Write down. By the triangle BHF. By the triangle BHF. Apply tan beta ratio. What's tan beta? Tan beta, you can write BF divided by T2, T1, no? T1. Tan beta, if bring this here, then BF we get FT1. BF we get FT1, right. Now we'll substitute people what? These areas and get this value of T1, right. Now substitute for star, right. Now substitute for star. Right, substitute for star. Now by star. BHF area, this area, how to find people? It's a triangle. What is that? Half base into perpendicular height. Okay, no? Right. Write down half. What is base? Base is T1. What is perpendicular height? Perpendicular height is BF. BF. BF only here we found FT1. FT1. That's fine. ODG area. This. What is that, people? Half base is T. This height W. What is W? We found earlier. FT. Yes. Right. ODG. Half base is T. W is FT. Don't put minus sign there, right? This is okay. This is okay. OAD area. OAD area. Half base into perpendicular height. Half base. Base is T. Perpendicular height. This V. We found this V to be 2FT. 2FT. That's also correct. OAD area also we found. Next one. AEH area. This area we need. This area. What is the area there? Half. Base is this. T. Perpendicular height is this. What is that? FT, no? This is 2FT. This is FT, no? Then this is FT. Am I correct? Yes. Right. AEH. Half base into FT. Right. People now simplify this and find T1. You can cancel down this if half, and you can cancel down this if, and here we get T1 squared, here T and T squared, and here 2T squared, and there T squared. 2T squared, here we get 4T squared. 4T squared, then T1 going to be 2T. Right? T1 is 2T. Who got this answer? Yes, good. Right. Got. Right. That time also we got. What is asking there? Find the time taken by C to overtake A from the initial moment of A. Not the T1 asking. What is asking? Time taken by C to overtake A from the initial moment of A. Initial moment of A is this. This T1 only 2T. Then what the total time? Capital T plus capital T plus what? 2 capital T. Then what's the time? What's the answer for the third one? 4T. Third one answer is 4T. Right? Then third one answer 4T. Write down. When you keep the answer, there is no marks for the third answer because third answer you have not provided there. Third answer asking what? Time taken by the C to overtake K from the start of A. Not only this, therefore. Starting point of A is here, no? T1, then 40. 40, correct, no? Right. Find the velocity of C as it overtakes A. People, velocity of C is given by this, no? This. I'll take this as U. How do you take U? The height from here to here. It is CB. CB is V plus what? BF. Understand? Right? Fourth one we can write. Fourth one. U equals V plus BF. But you know, people, BF. ft1 here, Vf is ft1. Put that. ft1. Right. T1, just now we found 2t. U equals V. We found 2ft, ft1, 2t. Right. What do you get? U equals 4ft. This fourth one. The fifth one. When C overtakes A, find the distance between A and B. When C overtakes A, find the distance between A and B. People, now, when C overtakes A has moved from O away, Z, given by OABC area. Then B has moved to leftward, no? Right. Can somebody tell me, when C overtakes A, this is the time point. Up to this time moment, BT graph of B is here, this. Then what is this area, whole area? This whole area gives us what? The distance B moved to the left from O. Then suppose B is somewhere here when C overtakes A. How do you get this area? This distance that is given by O, I, J, what? C area. Okay? At that moment, A has moved to right what? Z. So what is the distance between them? Yes, the distance B moved given by this area. The distance A moved given by what area, people? O, A, B, C area. Therefore, what is the distance between B and A? Yes, this O, A, B, C area plus what? O, I, J, C area. Understand? Yes or no? Yes. Then we can write. Number 5. Number 5. What is that? O, A, B, C area plus what? O, I, J, C area. O, I, J, C area. Right. Now find this area. People, what is this OABC area? OABC area. What is that? It's a trapezium. What is the area of a trapezium? Half sum of the parallel sides. One side is T, 2T, 40. Other side is 2T plus T. Other side is this, no? 2T plus T, 3T. The perpendicular height is this V, 2ft. Right. People, now we need this height also. Right. Suppose W dash. Can someone tell me, to find this area, this height we need, no? How take that? We can apply tan beta ratio. Here to here, 2T. This tan beta is given as F. This height we need. What is that? What is that? That's going to be 2ft again. Reason? When I apply tan beta ratio here, right? Shall we work out that? This way. Tan beta ratio, we can write here. That also you can calculate here. W dash divided by what? T, 2T. Tan beta is F. Bring this here. W dash. W dash is 2ft. Correct, no? Right. Then take here what? Half sum of the parallel sides. One parallel side is this, from here to here. The other parallel side is here. Here T, 2T, T, then 40. This is 2t. Half sum of the parallel sides. 40 plus 2t, no? This is 40. This is 2t. Sum of the half sum of the parallel sides into perpendicular height. Perpendicular height is this. What is that? W dash that I found here 250. Alright, now simplify this. 2 and 2 you can cancel down. 7 ft squared. 2 and 2 you can cancel down here. 6 ft squared. 6 and 7, 13 ft squared. Right, no? That's the distance between A and B. Right. Exactly 1 hour we took, but we must do this question within 15 minutes at the exam. Who got the complete answers? What? Right. Okay, good. Okay, come to question number 2. We'll finish this quickly today. Yes, a uniform rod, right. Number 2, read. A uniform rod AB of length 2A stays in equilibrium end A in contact with the vertical wall against the surface of a fixed smooth cylinder of radius r and axis horizontal. The distance of the axis of the cylinder from the wall is d, and rod makes an angle alpha with the wall. The vertical plane rod rest is perpendicular to the wall and the axis of the cylinder. Show that this answer. Who got this answer? Who got this answer? Yes? No one? Good. Right? Let's see. It's a very simple question. Right, this way we have a cylinder. Say we have a cylinder. It is fixed. Right. Here we have a wall. Okay. A rod is resting like this. In contact with the cylinder. Then you know a reaction coming here by the wall. The reaction is horizontal. Suppose it is S. It passes like this. Right. Now others stop talking. Right. Now the normal reaction coming to this rod by the cylinder. It is at the point of contact perpendicular to the rod. Therefore, that normal reaction should pass through the center of the cylinder. We know that also, right? Like this. This way, it is R. R, it is perpendicular to this. People, what is next one? Next one is the weight of the rod. And then finally, the rod is in equilibrium under the action of how many forces? 3 forces. We know whenever any object is in equilibrium under the action of 3 forces, the 3 forces must meet at a point. So therefore, the line of action of weight produced should definitely pass through the point this. Am I correct? Yes, all right. Then we'll draw like this, the line of action of weight produced like this. This is the weight now. W. Right, no? This is the correct diagram. Here, AB rod, no? Here A, this end is B. Right. The length is given as 2A, no? From here to here, A and A. 2A, no? Right. Our next one given radius is R. This is R. This is R. This is R. And another one given. The distance of the axis of the cylinder from the wall is D. Axis is means these people. A line passing this way, no? That's the axis. To that, the distance from the wall is D. This is D. I draw that with blue color. This is D. This length is D. This length is D. Right. And also, the angle the rod makes with the wall is given as alpha. This is alpha. This is alpha. Here 90. Okay? People, if this is alpha, right? Then when I draw a vertical line here, this way, draw a vertical line here. If this is alpha, this is also alpha, no? If this is alpha, this angle also alpha. We need them. Right. And the other one is if this is alpha, this is 90 minus alpha, this also therefore alpha because this is 90, no? Right. Right, people, I will take the length from here to here. The length from here to here, I am going to take as x. This length I am going to take as x. Actually, these lengths are very important in this case to take the answer. It's a very good question, very simple question, but very good question. This is, I am going to take as x. Right? X, this length is x. This is D given now. This blue length is D. From here to here, it's D. From here to here, it's x. Then you know this is going to be D minus x. Right. Right. We'll write one sentence like this. But people here, this length I have assumed as x. This is alpha. Then what is, this is 90. What is x cos alpha? X cos alpha is equal to R. First relation we can write, x cos alpha, write down. X cos alpha. X cos alpha is equal to R. Therefore, x equals R over cos alpha. Right. People now take this length as L, this length as L. Those lengths we need. This length I am taking as L now. Right, can somebody tell me how to find this L? This is L, this is alpha. Then what is this length from here to here? L sin alpha. L sin alpha is d minus x. Correct, no? L sin alpha equals d minus x. Thereby, we'll write d minus x over sin alpha as L. Okay. Now that's all. Now resolve the process horizontally for the equilibrium, vertical for the equilibrium, and take moment around A. That's all. Right. Now write down for the equilibrium. Resolving upwards. Tell me what do you get here? R. What is the component upward? R sin alpha. Should be equal to what? W. Right, correct, no? If this is 90 minus alpha, when we draw horizontal line here, what is the horizontal component? R cos alpha is equal to what? Yes. Understand? Correct, no? Right. Then write down. Resolving upwards, we get R sin alpha equals W. What is R? W over sin alpha. Right. Resolve horizontally. R cos alpha equals S. R cos alpha equals S. Really, S equals R. W over sin alpha cos alpha, no? Right. This is S equals W cot alpha. Right. Right. Now we'll take moment around A. S we don't need, but I found that. Ask him to find that. No. No. Right. Okay. Now for the equilibrium, we'll take moment around A. Write down. For the equilibrium, take moment around A. We'll take moment around A clockwise. Tell me the moments. Around A, when you take moment, S doesn't give any moment. It passes to the point A. R gives clockwise moment. W gives anti-clockwise moment. Understand? Tell me the moment of R. R multiplied by the distance from here to here. What is that? L plus the length from here to here. Tell me. When you take moment of R around A, for this R, the perpendicular distance from here to here, no? What is that? L plus this part, no? What is that part? Here to here, we assumed as X. This is alpha. Then what is this? X sin alpha. L plus X sin alpha. Understood? L plus X sin alpha. Why? එහි අපේ කල්පනා කරන්න විතරක් මේ බලන්නකෝ. මේකට තියෙන perpendiculars එක මෙතන මෙතෙන්ද මේ L and this part sum. This part is what? From here to here we assumed as x. This is alpha, x sin alpha. If you can't get this geometry by the diagram, nobody can work out this question, people. To give this practice only, I put this question. Some people, they might say, very difficult sums, they won't come to the exam. No, people, there's a chance. But when you work out this kind of question, your thinking ability, searching ability, right, everything will be improving rapidly. Therefore, rather than saying they are difficult, take the answers. There will be a certain place in the life you will get this advantage of doing this kind of questions. Right. Okay, R into what? L plus x sin alpha equals what? W into, what is the length from here to here? From here to here, it's A. If this angle is alpha, this also alpha. But we need from here to here the length. Here to here, it's A, this is alpha. Then what is this? A sin alpha. W into A sin alpha. This whole, people, now substitute for what? L by this and x sin alpha and substitute R. Keep simplifying. You get the answer. Hurry up. Right. Now substitute for R. W O sin alpha. L D minus x upon sin alpha plus x sin alpha. W A sin alpha. W you can cancel down. Right. Right. This sin alpha you can bring to right by using cross multiplication. Right. No? Then I'll write that here. Within bracket, here I take common denominator as sin alpha. Then this x sin alpha, this sin alpha should be multiplied by this sin alpha. There we get x sin squared alpha plus d minus x. D minus x plus x sin squared alpha. Now here, people, inside the bracket we have sin alpha, no? Another sin alpha here we have. Then they took the sin squared alpha equals a sin alpha. Right. I think I am correct. Here, after taking common denominator, we have sin alpha. This sin alpha also, I have sin squared alpha. Now by that we multiply this here. D. Right, people, from here and here, I take minus x out. Minus x I take out. Then here we get 1 minus sin squared alpha. This cross multiplication gives us a sin cube alpha. Here, d minus x. X, people, r over cos alpha. We found, no? Here, we found x, r over cos alpha. What is 1 minus sin squared alpha? Cos squared alpha equals a sin cube alpha. 1 cos alpha you can cancel with this. Now I think you get the answer. Yes, bring this right hand side. Therefore, a sin cube alpha plus r cos alpha equals d. Is it difficult? No. Only thing is, very small geometry you have to identify there. We resolved horizontally, vertical, we took moments, that's all we did. This geometry You should be able to identify the diagram, that's all. Nothing else. If somebody says this is difficult, people, no point of doing AL maths. No point of doing AL maths. Resolve horizontally, vertically, and took moment. To take the moment, we, using the trigonometric knowledge, we found the distance. That's all we did. Right, okay. We'll come to the last question. Okay, question number 3. Right, shall I erase the diagram now? Important thing is people doing the same questions again as homework. First time, without taking the time frame, do the question again. Secondly, do the question within 15 minutes. That is how we practice to work out the question within time frame. Okay, right, do them as homework. Right. Right, the next one, question number 3. The forces this act at the points with position vectors these, right. I'll directly mark them. X-axis unit vector I, y-axis unit vector j. Yes, at the point 6, 1, the two forces, 2 here, are 3 here. The point is 6, 1. Right. Here the point is -1, 3. -1, 3. At the point -1, 3, the force rightward 1, upwards 4. At 3 minus 3, the two forces are leftward 2. Right, people stop talking. More noise in the class. Right, here 2, this is 2. And -4, 0, the forces 1 here, 5 here. Okay, this is a negative x-axis. Right, I think this you can mark. No, you are familiar with forces and position vectors. Any issue marking up to here? No, I think everybody can manage very easily. Yeah. What is the first question? Represent the forces on the Cartesian plane. That is okay. Who got this answer? Yes. Right. Hey, got it. Right. What is asking? Find the moment of the system of forces about tau. Right. About tau. O is the origin. Right. We'll take. We'll take anticlockwise moment. Right. Tell me the moment of 3 around O, what moment? Anticlockwise, right? Why? Around O, when you push this way, system rotates anticlockwise. This we discuss in detail in the lesson, right? So once I produce a line here, to this 3, what is the perpendicular distance? This x coordinate, this is 6, no? 3 into 6. By 2, what is sense? Clockwise, right? Take the moment. 6 into 3 into 6. 3 into 6. By that 3 we get anticlockwise moment. 2 clockwise moment. Minus 2 into what? 2 into 1. And here, by this 1 around O, what is moment? Clockwise. What is height? By 1 into 3, no, 1 into 3. That also minus 1 into 3. By this 4 around O, again clockwise. What's the moment? For the distance 1, no? Right. Minus 0.1. By this 5 around what sense? Anti-clockwise. What is the distance? 4 plus 5 into 4. What do you get there? 20, here 18, 38, here 9. Around the anti-clockwise moment is 29 units. First one is okay. Calculate the resultant of the system, number 2. Is this wrong? Who got this answer at the moment? Is correct, no? Huh? Is it wrong? What is that? This force we didn't take. Yes, that's the problem, no? Right. Around 2 and another 2 we have, right? This 2 gives clockwise. This 2 also clockwise, no? Right. Then we get clockwise moment negative, no? This 2 gives 2 into the height is 3, 6. The other one also 6. Am I correct? Yes. That's why I just thought. Correct. Correct, no? These two both will give around clockwise moment, right? For this 2, this height y coordinate 3. For this 2, this is x coordinate, right? Tell me here. Here 18, 20, 38. Here 5, 9. Here 12, 21. Correct? Yes. Then what do we get? 38 minus 21 means 17. Correct? 17, yes. Right. Now, secondly asking, resolve horizontally. Asking the resultant, calculate the resultant of the system, resultant. Resolve horizontally. What do you get? 1, 2, rightward 3, leftward 2, 1, also 3. What is x? 0, right? X 0. Why? Rightward direction 3, leftward direction also 3. Okay? X 0. Find y. 4, 3, upward 7, 2, 5, downward 7. Again y also 0. Y also 0. Right. X 0, y 0. What is R? How do you find R, people? R is what? Square root of x squared plus y squared. Both x and y 0. Then what is R? R 0. R 0. No resultant. No resultant. No resultant, but we have moment around O. We have a system of forces. No resultant force. But there's a moment. Then definitely that system of forces should be what? A couple. Understood? Why? A couple only having purely a moment without a resultant. Yes. What is asking next? Show that the system produces two couple. Write down what? Write down system of forces has no resultant force. System of forces has no resultant force. But the system has a moment around O. But the system has moment around O. Moment around O. Therefore, system reduces to a couple. Therefore, system reduces to a couple. Okay. Yes, fourth one. If the system is in equilibrium, when the force minus I minus 5j is transferred to a point on the x-axis. Find the point on the x-axis. People, now this force we change from this point of action to another point on the same x-axis. But its sizes 5 and 1 we won't change. Since we don't change this 5 and 1, these two forces, still x0, y0, no resultant. Still x0, y0, no resultant. But you know, for a system of forces to be in equilibrium, there be two conditions satisfying. What? Resultant should be 0 and moment around any point should be 0. Understood? So therefore, since we don't change the sizes of this 5 and 1, only the point of action we bring to another point. Then secondly it says the system of forces in equilibrium. After taking this force to another point on the x-axis, the moment should be 0 for the system to be in equilibrium. Understood? Right? Then I'll mark that force here, somewhere here. Here 1, here 5. I take these coordinates alpha 0. Then around O, what? The moment of the whole system should be 0. Understood? Right, no? Then how take that? How take that, people? Right? Here we got moment of 5, no? 5 into 4, no, we took there. Where is that? This. For this 4 we put now what? Alpha. Then the algebraic sum should be equal to what? 0. Am I correct? Again, when I take moment around O, the algebraic sum of the moment should be 0, no? Since the system is in equilibrium, then I am going to write that equation easily. How? Put in here alpha now. The same thing we write and we equate that to what? 0. Understand? Around O, the moment should be 0. Am I correct? Why? System is in equilibrium. Right. Write down. Since the system is in equilibrium, moment around O should be 0. Moment around O should be 0. Okay. When you take moment around O by the rest forces, same thing come in, no? Only this we have to change. Only this we have to change. That is now 5 alpha. Okay. Right. Okay. That gives people, according to my diagram, that gives what? According to my diagram, 5 alpha should be negative because we took anticlockwise moment now here. Right. When that was acting here, anticlockwise moment. According now, what? Clockwise. 5 alpha. Therefore, here we must have what? Minus 5 alpha. Am I correct? Am I correct? Yes. Right, now take 3 into 6, 18, minus 2 minus 3, minus 4, minus 5 alpha, minus 12. Should be equal now 0. Take 5 alpha to right hand side. Right. Here 6, 9, minus 12. Right, minus 3. 5 alpha minus 3 by 5. We get alpha negative. What do you mean by that? Still, this force is on the negative what? X-axis. Yes, then what is the coordinate? New point is, x coordinate is minus 3, y coordinate is 0. Why? It is on the x-axis, no? Yes or no? Yes. Therefore, point is minus 3 over 5 comma 0. Right. Right, no? That is the end of the paper number 9. Right. People 1.5 hours we took. So once